Just decided, hey, why don't I just do a series of lectures based on my knowledge? So I'll be presenting kind of just short lectures on ROS and what it's used for, and maybe just setting up different packages and messing around, just experiment and see, what works, what doesn't. So just kind of to start off, we're gonna look at what is ROS. So ROS stands for Robot Operating System. And what it is a collection of tools, libraries, and conventions that aim to simplify the task of creating complex and robust robot behavior across a wide variety of robotic platforms. So, ROS is a very useful tool in the robotics industry because creating a robot can be a tedious process. But for example, if you were to set up a robot, I mean, you have to set up your motors, the chassis, all the sensors that you need in order to investigate your environment, and it can be a really tough process. You also have to consider the fact that it costs a lot of money to make a robot, and sometimes you just don't have the tools that you need in order to create the most advanced robot in the world. Sometimes you just have to keep it simple. So not only that, you have to consider your time too. Setting up sensors can be really tough. If you were just given a sensor, for example, let's say you had a sonar sensor to detect obstacles, you would have to create your own code in order to get that sonar to work. And sometimes it gets too complicated to the point where you would have to be messing with, how do I configure this one part of the sensor versus the other, and how do I output the data from these sensors so that way I could extract it and put it in my code. It just gets way too complicated. So what ROS does is it allows us to save time in setting up these sensor configurations. There could be someone that already created a package for this sensor, and you could literally just take that package, put it in ROS, and it'll output your data like in an instant. Another example would be multiple robots can be registered to recognize each other instantly. The way you can do this is you can just look at their IP address and add their addresses to the host network file. It doesn't take too long to do. It's a pretty quick process, and eventually in future videos I'll show you how to do this on your own robot. And honestly, ROS can be done on any type of robot. It's pretty easy to set up, and as soon as you get the hang of it, you'll realize, hey, I could use ROS for anything. I already mentioned here though that data from sensors can also be published instantly to manipulate for any algorithm, program, etc. So what ROS does with your sensors is once you have your package set up, you can take the data from it and actually it'll publish to a topic which you subscribe to, and you could say, hey, I want only a certain amount of data from this sensor. You can extract it and put it in your own code for algorithms, programs, etc. So let me just kind of switch to this laser here. Let's see if this works. Okay, sweet. So here's what ROS is not. Going to school a lot, I always tell students about ROS and how cool it is, and they'll be like, "Hey, yeah, ROS is sweet. I bet it's one of those awesome operating systems like Windows and Mac," but it's not. Um, I remember a situation with a student trying to learn ROS. They're like, "Hey, Rinse Tech, there's nothing popping up the screen, nothing pretty, nothing at all. It's like, what is it supposed to do?" So it's a tool. It's a collection of libraries used to set up your robot configuration in a terminal. If you don't know what a terminal is, basically what I can explain is like it's your file system in Windows or Mac, except you're using words to navigate through the file system. So instead of a click of a mouse, you use commands to do it. It is not a graphical user interface. Nothing will appear like a window with pictures or pretty buttons, etc. It's just commands that you type in the terminal to configure or access packages. If you haven't seen ROS before, I'll be showing it later on in future videos, so you'll see, kind of how that works. So it's definitely not an operating system. It's definitely not a GUI. It's just its own set of tools and libraries that you set up in your terminal to configure your packages. So, where do you use ROS? What is it compatible with? ROS works with Ubuntu distributions. Now, a lot of you may be asking, well, what the heck is Ubuntu? So you know that there's two types of operating systems. And for those of you that know everything about operating systems, you'll probably, tell me I'm wrong And yes, I am wrong. But for simplicity's sake, right now we know that there are two operating systems. There's Windows and Mac, right? Well, there's a third operating system that developers use called Linux. And Linux, I mean, that's, let me start that over. So basically, third operating system that developers use called Linux. And Ubuntu is an open source operating system which operates on Linux. It's as if you had like Windows 7 or 8 or 10 or whatever future one's going to come out. But instead, you have Ubuntu 16, 18, 20, older versions, and then newer versions coming out. And Linux is a part of that Ubuntu. You could use ROS on Windows, but why would you torture yourself like that? I mean, Windows isn't really useful for a lot of things, just saying. But I would highly recommend you don't use ROS on Windows. It's just going to make everything complicated. And you learn a lot more from installing your own Ubuntu distributions or dual booting your computer or even using Linux commands, because that's what people are looking for nowadays in jobs and stuff. So let's talk about the different versions of ROS. So there are different versions of ROS and Ubuntu. With each new release of Ubuntu, it will lead to a new release of ROS. So this following figure shows the compatibilities. So as of today, January 31st, 2021, these are the most common ROS setups that you can use. So if you download Ubuntu 16, you're going to have to use ROS Kinetic. If you download Ubuntu 18 and set it up for your OS, then you have to use ROS Melodic. If you download Ubuntu 20, then you have to use ROS Noetic. And I don't know if you already noticed, but it kind of goes up in alphabetical order. It goes from K to M to N, and I'm assuming the next one would be O. I know my ABCs. And Ubuntu 16 skips over two numbers to Ubuntu 18 and then to Ubuntu 20. These versions are the ones that are used commonly today, as of January 31st, 2021. But the new version is going to be ROS Noetic. Now you may be thinking, Rinstech, why don't you just use the most recent version? Well, sometimes it's best to use the version before the most recent version until the new version has better support. You'll notice that if you install the new version of ROS, like the most recent version, not a lot of packages will be supported on it. So it's kind of like what I personally recommend is you have to just use the version before until it gets sort of outdated and there's more packages supported on the newest version. And you'll realize when that's going to happen. It's pretty easy to detect. So in this case, the system that I recommend you install would be Ubuntu 18 and ROS Melodic. You could use ROS Kinetic in Ubuntu 16.04, and that'll be, that works fine. But right now, the most commonly used system is this setup here. So let's just kind of go over some examples of how the ROS is set up. So let's say we have, okay, let's come up with an example. So let's say, even though this is physically impossible right now because it's out of stock basically, but let's say you got a PS5 for Christmas. Yeah, let's say you got a PS5 and you got like this box here of like PS5 stuff, the usual. Let's put PS5. And you're a person, right? And you're like, yay, I got a PS5, woohoo, now you got to set it up. So let's say you take all this stuff out of the PS5. All this stuff you're going to have is you're going to have the console, you're going to have the controller, and you're going to have, let's say, a TV screen. All these things are out of the package and they're not connected to each other. So this is how, for example, ROS works. You, as a person, are... I should have wrote it off first. Let me fix that real quick. Okay. You, as a person, are the master. Right? Yeah, gotta get that. Okay, let's say you. You have to figure out how to set up this system to work all together. The console, the controller, the TV screen, you are the input. So, let's say we have controller. we have TV screen, and we have, what was it again? Console. I'm personally a PC user, so I don't really like messing with consoles because it's disgusting. But anyways, uh, you're the master. There's the console, the controller, and the TV screen. So you, the master, have to figure out how to get all these things to communicate together, so that way you could game on like Call of Duty, Cold War, or something, whatever kids play nowadays. So okay, if you're gonna be interfacing with everything, you have to start with setting up one object. And the one object you'd probably want to set up is the console. So let's say you go to the console and hook it up. Now it's powered on, right? Well, here's the issue. How are you going to control the console? Or how are you going to know what's on the console? So if you're going to get this to work out, what you need to do is to set up a... Ooh, let me switch this around. That way it's easier to identify. Let's put console over here. And then let's put controller over here. Just to make it better to understand. There we go. Let's move this over. Okay. Okay. Again, let me repeat real quick recap. You're the master. You got this PS5. You got to set it up. Not everything's connected together. You got to connect it. So what we just did is you interacted with the console here. Right? But the console, that's all you see. It's just the console. It's powered on. There's nothing to see. There's no way to put any input. You don't know what's going on. So what you need to do as the master is connect the TV screen, right? So now you have the TV screen connected. It's on. It's pitch black, and you have the console connected, but there's no output from the console. So you need to get these two things to communicate together. So you take a HDMI cable, connect the console to the TV screen, and now you have a connection between the two. So now you can see the output on the TV screen from the console. But how are you going to control it since there's no input? You know, it's just a console and a TV screen and it's looking pretty, but you want a game on this thing. So what you're going to do is connect the controller. And the controller is going to connect to the console via, let's say, Bluetooth, because wired is kind of getting outdated. So we're going to use console and controller. And now that the controller is connecting with the console gets input from the controller. Meaning that you now have this whole system where you have the controller here communicating with the console to put in some input, and you'll see that input from the TV screen coming over here. So now all these three, let's say in ROS terms it's called nodes, but let's say these three nodes are communicating with each other. Now you see the output from each towards yourself. You're getting information back from each. From the TV screen, you're getting back like vision capabilities, console. I guess you could say like well, let's say controllers like input. Console, I mean that could be somewhat of a computer. Yeah, we could say it's a computer. And all this information is relaying with each other. All right? So, now let's move on to actual ROS. So we're going to have the same setup again, but instead of a PS5, we're going to have an actual robot. So let's say we have let's say we have an autonomous vehicle, right? Because autonomous vehicle counts as a robot. Okay, so we have this autonomous vehicle. Or let's say it's not autonomous yet. Let's say it's just a vehicle. And we're going to turn it into an autonomous vehicle. So we have this vehicle, right? And it's this master. And let's say this vehicle has a computer inside that controls everything. Let's call it like a Raspberry Pi or something. Okay. And we have a bunch of sensor configurations. So what's one thing you need to control in a car to get it autonomous? What you need are motors, right? So we could say motors. And what else could we add? We want vision capabilities, so we could say we could add a camera. And for the heck of it, let's put an obstacle detection sensor. So let's put LiDAR. If you don't know what LiDAR is, it's just a laser scanner, and it just scans boundaries. Usually just shoots one flat plane. Pretty easy to use. I say that. I don't know if you ever used it, but so we have a vehicle, we have motors, we have LiDAR, camera. Alright, so the master is the Raspberry Pi in this vehicle. It could be like a tiny RC car, who knows. And we want all three of these things to communicate with each other, actually all four. So what we need to do is create a connection between the RPi and everything else. So an easy thing we could do is actually we can connect the motors to the, oops, wrong one. The RPi to the motors here. So that way we can at least get the vehicle moving, right? But we need some sort of information to relay back to the motors so that way it can either turn left or right based on how obstacle detection is implemented. So what we can do is connect the RPi to the LiDAR. And this LiDAR is going to give us back information of what's being scanned. So usually it's just like a matrix of numbers. I believe it's like 1 or 0s telling you if there's an obstacle, if there's not. It's more just kind of like scans, but I'll show you in later videos what it looks like. So now we have these two communicating with the RPi, and we have motors also communicating, well, with us via left or right, outputs. Now what we can do is take this information that we have from the LiDAR, send it to the motors, and the motors will basically communicate with the LiDAR as well, and it'll give us outputs such as left or right based on if there's an obstacle on the way. Right? And the LiDAR will tell us scans here for boundaries. So I'm going to put scans for boundaries, left or right obstacles. And now we have the camera. So even though we can detect boundaries, let's just say we want to know what this object is that we're detecting. So we can hook up our camera to the RPi, and the camera, we can hook it up to the LiDAR to give us information of what these objects are going to be. So we could say visual reference. So this communicates information back to the RPi, and then we can communicate this information back to LiDAR, which means this information can also go to the motors as well. They're all linked together. So this is basically ROS. So the way we call this is the master node here, this circle, and we have just regular nodes. We have node 1, node 2, and node 3. And what these arrows represent, we could say the blue, and I know it's not perfect because some of the arrows are kind of not facing the right directions, but the blue would be subscribers. And the red would be publishers. So what we're doing with the RPis, we're taking these sensors and we're subscribing to the information that they oh, wrong one. Where is it? This one. We're taking the RPi and we're taking this information from the camera and we're subscribing to it, so that way we can receive the messages. And what the camera's doing is actually publishing a topic, and it could be like let's say this topic is called RGB image. We're going to take that information that we get and relate it to the RPi, so that way we can take the data that it provides and manipulate it. So same with the LiDAR, and we would have a scan topic, and the RPi would subscribe to the information provided by the scan topic, and the scan would publish the data to the RPi. Now, for the motors, there isn't really a topic for the motors, but if you really set it up well, you could have something called a twist message. And what the twist message does is I don't know too much about it in detail, but I'll eventually learn it so that way I could show you guys, better reference. But the twist message is what you use to publish information to the motors. So you could publish the motors to go left, you can publish them to go right, you could publish the speed that they go at, the angle at which they turn. It's just basic information like that. So just for reference, I'm going to put like steering, speed, that type of information. And we can take this topic here and we can just relay that information back to the RPi, or we can take this information, relate it to the scan and the RGB image. And that's just the basics of ROS, the best that I can explain it in simple terms. Again, you can relate it back to the PS5 topic and then use ROS again, just to relay back. I will be posting resources down below the YouTube video just, to give you more background information. But this is what I believe would be the easiest way to learn ROS. In the next video, I'll be showing you how to install it or how to install dual boot. There'll probably be different videos on it. I'm still planning this out. But let me know what you guys think. If you have any comments, just let me know what I can improve on. Maybe lessen the video time, the resolution, etc. And thanks for watching.